And now we will continue with expert presentation. And first, I give the floor to Ms. Svetlana Brzev. She's a technical advisor and also president of Serbian Association for Earthquake Engineering.
Good morning, everyone, and welcome virtually to Novi Sad, to Serbia and Novi Sad. In fact, I'm in Belgrade, so I cannot welcome you really to Novi Sad. Only Lana and Maria can. So I'm based in Belgrade, Serbia. I'm originally born and brought up in Serbia and educated mostly here. But in 1990s, I immigrated to Canada. And so major part of my technical career was based in Canada, and right now I'm mostly based in Serbia, but I still have a ties with the University of British Columbia in terms of research and a little bit of teaching. So most of the time I'm here. So in 2018, I, with a group of colleagues, I founded Serbian Association for Earthquake Engineering, and I'm the president. So I'm very active in here in Serbia. I'm a structural engineer by training, and my interest in earthquake engineering started with the Montenegro earthquake in 1979 when I was a student, engineering student, and I visited with my classmates the site of the earthquake, and I was really shocked and intrigued with the way interested to learn the ways to improve, to prevent consequences like that earthquake and many others. So I will be giving a short presentation on an overview of construction techniques in Serbia. Here in this project, I'm mostly involved in the package WPT2 and was contributing to the documents. So the purpose of this presentation is to be short because we try to give a longer details about Novi Sad, but so this is a little bit an overview of some of the content is already in the documents that have been published by the project. So as far as Serbian urban heritage structures are concerned, they date mostly from 19th and 20th century. There are some examples of older buildings, but most of them were demolished because Serbia has also a rich cultural heritage, but also rich heritage of wars and destruction in the past, in the history. So I will just say a few words about just to give an introduction overview of construction building typologies in Serbia, construction practices. There were some really good projects which helped us a lot in this effort, such as Tabula project, it's international project, and with participation from Serbia. It was colleagues from architectural Department of Architecture, University of Belgrade, who prepared this. So for Tabula, and this is included in the document of WPT2. So the construction practices were divided by construction periods on the left side before 1919 and then all after 1919, and then also by the type of construction. So if you look at the period before 1919, I would say I would just use this opportunity to just give a bigger picture. Of course, for let's say rural and also urban, suburban buildings, most population lived in single family housing. That is actually a fact even today, because about 90% of buildings are low rise, and they're mostly one or two family as far as residential buildings are concerned. And then there were some freestanding buildings at that time, which were built, let's say, 19th century or beginning of 20th century, because we're talking about period before 1919. Then also houses in a row, and but mostly they were really low-rise buildings up to 2, 3, 4 stories. Not more than that. So these are the heritage buildings or historic buildings from that period. And this Tabula project was focused mostly on residential buildings, so that is not the focus necessarily of this project, but I think it's a good overview of, gives a big picture of these construction techniques. So as going back to Adriseismic project and the classification of building typologies or main structural types, There were 7 types, four of them. First 4 are related to masonry buildings, and the last 3 to concrete buildings. So I'll give a little bit of overview and examples of buildings from these types. And they're relative to, actually most examples are from Belgrade, not Novi Sad. So ancient masonry buildings are all those constructed before 1900s, and in that period, the use of load-bearing masonry was, of course, prevalent, and there was use of earthen construction, but not adobe. It was some form of rammed earth in the some other type of earth construction, and then also brick masonry construction started to be used in Serbia in around 1850s. The first applications of brick masonry and brick manufacturing in Serbia was dates back to that period. So this is an example of, on the left-hand side, house of residence of Princess Ljubica. She was a wife of he was not Prince Mihailo Obrenović. And then the next one is the Kapetanishno zdanje. It was also an public building built in 1863 in the center of Belgrade. So both of these buildings are in Belgrade. Talking about ancient buildings with anti-seismic protection, that is a very interesting topic, and actually, of course, rings lots of bells when you are in Italy, because there were lots of examples of buildings of this type. In Serbia, there are not too many types, not too many examples, in the sense that they have been in Italy with the use of iron ties or metal ties. This is an example actually as a part of restoration of a monastery Žiča, which is close to Kraljevo, and Kraljevo was affected by the 2010 earthquake of magnitude 5.5. So this was installed not in the original monastery, but as a part of restoration or retrofitting, in a sense, after the earthquake. So this is a brick masonry building. Most monasteries in Serbia are brick masonry structures, and there are many very nice and interesting monasteries which are heritage structures. So the only type I would say that is anti-seismic protection in terms of older construction or technology that is we could qualify anti-seismic protection is this technology of Bondruk. This is old Turkey is coming to was imported to Serbia by Ottoman rulers. Serbia was ruled by Ottoman Empire for 4 centuries. So between 16th and 19th century, 15th and 19th century. So they imported this type of wooden construction that was filled with bricks or other filler materials. And this type of construction performs relatively well in earthquakes. So these are examples. This is actually my neighborhood in Belgrade, where all modern buildings are present, but there are some examples, all buildings with this Bondruk style technique. You can see these wooden elements, and then this is bricks. And this is actually a headquarters of the Cultural Monument Protection Institute in Belgrade. They're in charge of protecting all cultural heritage in the city, and this is one of the best spots in the city at the in Kalemegdan Fortress, and the building also has elements of this wooden construction combined with masonry. Pre-modern masonry buildings, we classify them up to beginning of 20th century until 1964, when the first seismic code of the former Yugoslavia, Serbia, as you know, it was a part of Yugoslavia at that time, so was published. So these buildings are load-bearing masonry construction, massive structures with relatively thick walls, brick masonry, and without any seismic provisions. Floor systems varied, effect from the 20th century, use of concrete floor systems in Serbia for this type of buildings like the one that's shown here. This is actually a concert hall in Belgrade, used for classical music, but it was endowment by one person, Ilija Kolarac. And right now it's used, I'm not sure what was the initial intended use. It was constructed in 1932. It is an example of many buildings, similar buildings in the center of Belgrade, in around urban squares. So, so anyways, this is just one building of this type. But what I would like to know, this is all for masonry buildings. And then after 1964, of course, we have modern masonry buildings with reinforcement. And so they're not covered here. So pre-code reinforced concrete buildings. So the beginning of concrete construction in Serbia is around 1900s. In fact, the first application was in a museum, in National Museum in Belgrade, but it is not the load-bearing structure. It is a floor system, which was made of reinforced concrete in 1903. And subsequently, so you can see the height is 3 to 4 stories, and a bit taller building is Hotel Moskva, which was built around 1908 or something, a few years later. Also, which has concrete floors, but also has a some concrete walls. So it has other concrete elements in the vertical elements. So this is probably the first structure in Serbia with vertical concrete elements. And it has very interesting history. It had involvement of Russian architects. Actually, that's why it's called Moscow. Moscow means Moscow. It was sponsored by the society, I would say, Insurance Society of Russian Insurance Society. So involvement of their architects and engineers was there in combination with Serbian architects and engineers. So so then more modern, but also old. We could consider them old or older buildings, which are considered as heritage, are, for example, Ethnographic Museum in Belgrade, which was 1935, and it was actually built as a stock exchange. It is at a beautiful square called Studentski Trg, Student Square in Belgrade. And also around that same square, there is a building of the Faculty of Math and Science at University of Belgrade, which is I would say, a typical building of 1950s. So both are reinforced concrete buildings. So these are samples of different era of the application of concrete construction, but both of them are before 1964. More modern concrete buildings look differently. Of course, this is an example again around the same square, which is called Student Square in the center of Belgrade. This is the Faculty of Philosophy, Department of Philosophy, University of Belgrade. So it is like a complex of buildings, and it is concrete frame construction with infills built in 1970s. So it is typical architecture from 1970s in Serbia. It was built constructed after the first code was published in 1964. So it does have some seismic provisions, but at a lower level than after 1980s. So this is all I'm presenting. In fact, I picked a few periods that I thought are interesting to show. These examples are from Belgrade, but similar examples could be found in other cities, Serbian cities, which are of interest to this project. Of course, Novi Sad, but also Niš, Kragujevac, and maybe some others. So, so this is an overview of construction of building typologies. I'm not doing an overview of, let's say, wall construction techniques or floor construction techniques. This could be a very long lecture presentation in that sense, but we will illustrate that on example of these Novi Sad buildings. And of course, more details about that are given in the document that was recently prepared. Congratulations to the team, Georgia and colleagues, for putting it together. It is a very comprehensive document. So section 4.4 from Serbia documents all the construction techniques for other aspects, as I mentioned. What I would like to end this presentation with is the hazard, seismic hazard. We need to consider, when considering any intervention or any consideration of even thinking of intervention, we need to consider a level of seismic hazard that we have at a particular site. So Serbia, even though it is adjacent to, let's say, Romania, and it's also adjacent to Croatia and Montenegro, which have all more frequent earthquakes, particularly Croatia recently. Serbia has, at least officially, according to our seismic maps, has significantly smaller hazard. So both Belgrade and Novi Sad are shown here. And you can see the arrows, black one for Novi Sad, the white, the red one to Belgrade. So this is a zone with seismic hazard acceleration level of 0.1 G. That is for the seismic hazard level that is considered by the Eurocode 8. That means 475 year return period earthquakes. There are some pockets in Serbia. If you look at the very bottom, in fact, maybe you cannot see it, at the bottom of the south, there are some which has higher accelerations of 0.2 or 0.25 even, but they are mostly very few territory-wise. It's small and it is not urban area. So most urban areas would have this relatively small hazard. So I had fun last weekend. Actually, I was working and I thought, why don't we put together this to compare, to look in perspective and compare sites in Serbia with, let's say, sites in Italy and Slovenia. I think Slovenia as a high hazard region. So you can see these are spectra from Eurocode 8 for Novi Sad. These are elastic spectra, but the Novi Sad with the acceleration for type A 0.1 G. For Bologna, I tried to understand Italian and looked at a beautiful website which documents that. So I think I figured out it is 0.15 G for basic, I think, or one of the locations in Bologna. It is 0.25 G. So you can see where is Novi Sad and Serbia, or urban centers in Serbia relative to Italy and Slovenia. So we have relatively small hazard. It does not mean that earthquakes do not happen, but that may be also a reason for maybe less attention to earthquake-related issues in Serbia. It is not an excuse, but it is certainly a fact that earthquakes do remind us of the need to do something. So it is wonderful that this project does it without, to help us protect the heritage for future earthquakes. So as a closing remark, the purpose of this presentation was to provide an overview of construction techniques in Serbia, specifically to give a context of building typologies and historic periods of practice. And seismic hazard has been also discussed briefly to provide a sense of comparison with other countries in the region, since hazard is an important criterion related to prioritizing seismic protection of heritage and all other buildings for that matter. Further discussion today will be focused on Novi Sad. So this was a general introduction to Serbian, I would say, construction practices and a little bit of background, short one. So I believe, thank you very much, but I believe the questions will be at the end, as Julia indicated. But if I'm not sure if there is any question now, otherwise I will stop sharing the screen. So I hope you heard me well. I didn't ask that question at the beginning.
We heard you well, Svetlana. Thank you very much for your useful and interesting presentation. I hope that our partners enjoy too.